Isn't that the way? So I don't know if you've looked at the website or not, but I'm using that that tutor's tool to generate the website. So you're familiar with that anyway from some other modules. I think most modules in your program actually use it. So today we are going to go into this card here. This is the behind this card is the set of slides that I went through last January when I spoke to you. So if you want, you can flick through those, but my focus is going to be on this one here. And when I spoke to you back in January, I kind of explained what the idea of the module was, and I explained it on the basis of what you knew back then, but of course you've done a lot of enterprise web stuff in the meantime. And what I could say now to you quite simply is that this module is all about looking at a framework that is an alternative to Svelte. It's as simple as that. It's a one-liner. So that gives you a kind of a context for it that you can relate to. I'm not assuming everybody has done some Svelte development. Some of you may have used it in your assignment. Some of you may have not. I'm not assuming that you have. I am kind of assuming, I suppose, that you've got a sense of what the target space for something like Svelte is, or as we call them, single page app frameworks. And we're going to be looking at an alternative, as I said, a framework called React. So React is a single page app framework. That's going to be the sole focus of this module. So it's nice and focused in that sense. Okay, so the slides today anyway are behind this card here. I'll just pause for a second just in case anybody has any initial kind of questions about stuff that I should cover at the very first lecture and usually forget to do so. No, fine. Right, so React. And this is kind of the agenda. I'll just quickly give you some background to the framework. I won't spend a lot of time on that. React is all about web-based user interfaces. It's kind of the V part of MVC. You're familiar with the MVC pattern from a lot of the web stuff that you've done. We're just concentrating on the V part, or React just concentrates on the V part. I'll come back to that a little bit later on. Why that was a conscious decision that the React designers made. I'm just going to pause for a second. Now people can see my screen and can hear me. Isn't that right?
Yeah. Yep.
Right. Okay. Third item there are JSX. JSX is this kind of secret sauce that React gives us. It's an extension of JavaScript, and we'll spend a lot of time writing JSX code, if you like. There are two tools that we will use throughout this module. We'll use one more than the other, really. I'll introduce both of them this week. And really from kind of next, well, from the first lecture afterwards, maybe our main focus will be on only one of those tools, and then the second one will come back into focus at the very end again. React is all about developing what are called components. So you know what the notion of components are from the first material that you've covered. So React is very much a component-based library as well. How we structure components is what we need to look at, though. I'm not sure if I don't really expect to touch on the last topic in that list there, that material design. That's why I've got it in brackets. That'll probably come back into maybe next week. Now, in this kind of software world, an awful lot of software tools, not just in the web space now, but a lot of software tools and frameworks that we use in the software world, they actually kind of begin life as an in-house project in a software house. And the organization decide to actually open source it to the general community, and that's the case with React. React actually began life as an in-house project in Instagram. This is when Instagram was, before it was bought up by Facebook. This is back in the very early noughties now. And when Facebook acquired Instagram, I don't know what the framework was called back then, but they liked it and they used it a lot for a lot of their in-house stuff. But they actually, which is great, they decided to open source it and make it available to the general community. That was back around 2012 when they open sourced it. So that's why we are actually able to use it today free of charge, if you like. And what it is, what React is, or React.js is, as I've already kind of indicated, it's a JavaScript framework for developing dynamic web-based user interfaces. The kind of techie term, which now makes sense to you, is to say that React is a single page app technology. Some people say it's a framework, some people say it's a library. It's kind of a nerdy argument. We won't get into it. It's not that important. Back around 2012, like single page app frameworks, there were a lot of them around back then, and they were almost appearing on a half-yearly basis. You know, they were popping up all over the place. But back then in 2012, all of the single page app frameworks that existed at the time, I'm mentioning some of them there, one called Angular, which still exists, Ember, that still exists too. Backbone doesn't really exist anymore. It's fallen off really in popularity. But back then, they all followed this MVC pattern, which kind of meant that the way you structured your code was based on you developed model parts, view parts, and controller parts. Okay, that was the kind of best practice at the time, even though MVC began life as a pattern for developing server-side code. It was being used on the kind of client side as well. But what the React design team decided was that they weren't going to follow MVC at all. And that was kind of a conscious decision, and it kind of broke the mold. They were only going to focus on the V part of MVC. So that was the first kind of difference between React and the rest. The second thing was that back then, pretty much all of the single page app technologies used what's called a templating technology for developing the V part. And the React team decided that they weren't going to follow that. They were going to adopt what they called the component model. Now, of course, the component model, pretty much all single page app frameworks today follow this component approach, but React arguably were the first to do it. So they kind of broke the mold, is kind of what I'm getting at in this kind of background stuff. And, you know, this kind of arguably was their rationale for taking the component approach versus the templating approach. Believe me, now I'm not going to waffle on about too much about this because we want to get into the nuts and bolts of it. But their argument was that you got better separation of concerns, in the sense that back then in 2012, when you were using one of these frameworks that took the templating approach, the user interface part of your code base was broken up into JavaScript and HTML, and there were physically different files. Now, obviously, they were interacting with each other, so you kind of found yourself as a developer flipping between a HTML file and your JavaScript code and jumping back and forth between the two of them. That isn't the case with React. With React, both your HTML and your JavaScript is physically in the one file, which is the case with Svelte as well at this stage, because Svelte is component-based as well. And you know, you achieved. They kind of argued that this separation between HTML and JavaScript in different physical locations was an artificial separation of concerns. They really belonged together. The second thing there is, from a semantics point of view, when you were using a templating approach, you had to learn a different kind of templating syntax. And usually it was okay, but it was kind of underpowered. It wasn't as powerful as a language like JavaScript. Whereas with the React component model, you were using JavaScript and HTML only. You didn't have to learn this extra templating kind of syntax on top of it. Plus the fact that you were now using two very well-established technologies, in particular JavaScript, which is a fully functional, powerful language, whereas the templating syntax that you had to use, you didn't tend to have the same kind of expressiveness that you do with JavaScript. So React is all about building components or implementing components as opposed to creating templates. And also the second point that we want to take is that React is all about the user interface. It doesn't care about business logic. It doesn't care about the model part, the end part of MVC. Now, business logic arguably shouldn't be coded as part of your single page app anyway. That's probably something that should exist on the server side. But certainly this idea that they weren't going to deal with the M part of MVC, where the M part stands for model, or the data part of your single page app. Now that story has kind of changed in the meantime. The overall point I'm trying to make here is that they took a very narrow focus in terms of what they wanted React to be used for. The end part is still very important, and what we tended to use, what a lot of developers use now, is they use another library in conjunction with React, where this other library takes care of the end part. If you've read anything about React, you may have come across references to something called Redux. So Redux is another library, a separate library or separate framework that's used with React, where Redux is just concerned with handling the data modeling part or the data management part or state management part of your application. We'll come back to these things a bit later on anyway. So React components are all about developing the V part of MVC. It's just the user interface. And a React component is comprised of two parts, I'm saying here. It's comprised of the UI description part. And because it's web-based, you know, we're still going to be using HTML to code our UI description. By description, I mean the layout of what you see on the screen, its structure. The UI description, and then there's the UI behavior. By behavior, I mean what happens when the user interacts with the web page, if you like. How does it behave? And we implement behavior using JavaScript, surprise, surprise. Now, today, this week, or in this lecture, I'm only going to be concerned with the UI description part. How do we code the UI description or the user interface description in React? And it'll involve using this syntax called JSX. In the next lecture, we'll introduce more dynamics to our web page, and that's where UI behavior will come in. What was unique about React back then, it isn't unique anymore though, is that both the UI description and the UI behavior physically existed in the one file, in the one module or the one unit, if you like. They were co-located. That wasn't the case in all of the other frameworks, its competitors back in 2012, 2013. So there was tight coupling. And, you know, arguably these are the benefits that they made back then as to taking this approach to keeping the UI behavior and the UI description in the one physical location, in the one module co-located. You got better composition, and we'll see that a lot later on, where we bring components together, we compose components from other components, this composition approach, and better reusability as well, the idea that we can use components for different use cases, if you like. So we're narrowing it down now. We're looking at how do we create a user UI description using the React framework. The React framework is broken up into a couple of different modules or packages in the Node terminology. There's two in particular. There's a package called the React, and there's another one called React DOM. Now, it seems like an oversimplification, but it isn't. The React library, or the React module, sorry, just provides one method called createElement. And if we invoke that method, what that allows us to do is to create a HTML element, like a paragraph or a header or a div or whatever. Okay, that's that. In the React DOM package, it has a method called render. And what that allows us to do is to attach a HTML element to the DOM. Now we know that when the DOM being your document object model, that internal data structure in the browser, we know that when you manipulate the DOM in the browser, what the browser will do is it will reflect that change in what it displays on the screen. So if you attach something new to the DOM, which using React we can do by using this method here, then by changing the DOM in the browser will reflect that change in what it displays on the screen. So we use this method to create HTML elements, and then we attach them to the DOM using this method. And it's as simple as that, really, in terms of how we build user interface descriptions in React. If we look at those two methods in a bit more detail, The React.create element, that method, I'm telling you here what its signature is. In other words, what arguments do we pass to the method? You've got to tell it what type of element you want to create. You've got to associate any properties that you want to have associated with that element. In particular, that might be, do you want to associate some CSS class or classes with the element? Do you want to have an event handler associated with the element? That's what I mean by properties. And thirdly, then, and really importantly, is what children do you want that element to have? Now, we know, of course, that HTML, when we write HTML, it's kind of a nested data structure. We can have elements within elements, as in we might have a div, and inside in the div, it might have a paragraph followed by a header, followed by a button or something like that. The React.create element allows us to express that kind of hierarchy by using this third argument here. We'll have an example of this in a minute now. So the good story is, though, that we don't actually use React.create element directly. If we did, then it would really, the React framework wouldn't really have caught on at all. We don't use it directly because it's far too cumbersome, but indirectly it's being used all over the place. And I'll explain what I mean by that in a few moments. The React DOM.render method, it's a little bit more straightforward. It just takes two arguments. You give it the element that you want to attach to the DOM. So the element would have actually been created by this method. So whatever that kind of returns, we pass it to the render method as the first argument. And we also have to tell it where on the DOM do we want to attach the element? Where should it appear on the screen? Let's look at some examples. Now, if I go back to the website, the examples I'm going to look at are contained in this archive on the right there. So if you click the card on the extreme right, you'll download a zip file. And when you unzip it, what you will get is this folder here. Now, I did mention to you way back in January, I'm sure you've forgotten, that I use VS Code throughout this module. And I know Eamon didn't use it, he's a WebStorm fan, but I do use VS Code. I'd recommend that you use it as well. It's not absolutely mandatory, but all of my kind of labs have screenshots from VS Code. So I'd get into it if I were you. It's good to have it on your CV anyway. So just go to the VS Code website. It's very easy to install. You download it, unzip it, and that's what it really, there isn't really much into the installation procedure. And kick it off. It's just an executable. And so I've done that. Here's my VS Code kicked off. This is what you see when you start up VS Code initially. And VS Code is a text editor, by the way. It's not an IDE technically, but and so if I want to import something into VS Code, I can just do it by drag and drop. So I'm going to drag that and drop it onto my VS Code. And this is what we have. Okay, and I'm just going to look at some of these HTML files now in a few minutes. Just before I do that, there is a README. And the README just has a link to a short little YouTube video there that I made last week. It's only about 8 or 9 minutes. And it explains to you how you should set up VS Code for this this little project. Okay, there is one little plugin that you need to install with VS Code, and the YouTube video explains how you do that. So have a look at that beforehand. Right. Now, I suppose just a minute on maybe VS Code. So in terms of the language of VS Code, this is obviously the editor area. We see our files and our folders over here on the left. Down here is what it calls the panels area. The main thing that's in terms of panels is that you can actually start up a shell session within VS Code, or a DOS session, whatever operating system you use. And I have it here at the moment. I've opened up a terminal session. The way you do that is, and I explained it in the video, how you start up a terminal session, what it calls an integrated terminal session within VS Code. In other words, I just have the ordinary shell command prompt here, and I can submit commands from here, which you will be doing quite a lot of. On the extreme left here is what it calls its activity bar. Now, in terms of activities, the main one is what it calls the Explorer activity, and that's the mode that you will be in when you're doing editing. Down here is the extensions activity, which is where you go if you want to install any plugin, and you will need to do that for this particular little sample project, and I explain in the video how you do that. This one here is its source control activity. VS Code has got really, really good integration with Git. I'm not going to go into it, but it does. Maybe you may have some free time down the line, and it really makes working with Git so much easier. Even though I will do a lot of Git stuff from the command line in the labs, but it does have very good integration, just by the way. Now, I want to get back to the focus of what we're on about here, though. So what I've actually installed is a simple little HTTP web server as an extension to VS Code. And the way I start that web server, and again, the video explains how you do that, is if I click on this link down here in the status bar, this is what VS Code calls its status bar. If I click this link here, it's going to start a local HTTP web server, just a bog standard web server, now nothing fancy. And it will serve up the contents of what you see on the left. So let's just do that. So what you're seeing here is the contents of the project that I have currently opened. So for example, I've got a file called 01 description.html, and here it is being referenced here. Now, this is what I want to look at. Just pause for a second now. I know I'm flipping through stuff just in case anybody has any questions. And by the way, if you have any questions along the line, just feel free to just butt in, and I'll take it that way rather than kind of raising your hand in Zoom and that kind of stuff. No, okay, let's look at this. This is a standard little, it's just a standard HTML file. You know, it's nothing fancy really. And so let's see what's in it. And really all we're interested in is this part here. So what am I doing? I am using react.createElement to create a HTML element. And it looks like I'm creating a H1 header. This is how it looks a little bit clumsy, but this is how I associate a CSS class with that element. You can't use the word class in JavaScript because class is now a reserved word. This is class as in CSS class. You know, when you're writing ordinary HTML and you want to associate a CSS class with a particular element, then the attribute name that you use is class. But as I said, because class is now a reserved word, in JavaScript, it couldn't do that, so we used class name instead, and you see that a lot. Every time you see class name in any of your React code, it's really a CSS that you're referring to. And it looks like it's looking for a CSS class called this, and down here I've got my bit of CSS, and it's not very interesting really. Okay, it's just a very tiny bit of CSS. Go back to my file, sorry. So I'm using the React framework to programmatically create a H1 element, associate that bit of CSS with it, and language in this case, because it's a H1, technically I suppose language is a child of the H1, but it's really the text of the header. So that creates a H1 element. Here it looks like I'm creating a set of LI elements. I don't have any properties, and each of the LI elements have this as its text. Actually, do you know what I should do now first? Sorry. I should really show you what this page produces, which is that. Do that first. Back to my React code, create a bunch of LI elements. Next, I create a UL element to wrap all of those. Now, in this case, I'm creating a UL element and it has 3 children, whereas any of the elements we've seen so far have had 1. That's a nice thing about JavaScript as a language. As you may know, you can have variable linked parameters. It's just a feature of JavaScript. It's not a React thing. So I've got a UL element, no properties, no styling or anything else. It has 3 children. And that kind of makes sense because I'm wrapping my LI elements inside a UL element. Next, I create a div with a bit of CSS. The div has 2 children, which are 2 of the elements that I've created above. So what am I doing here? I am programmatically creating a bunch of HTML elements using the React.createElement method. Finally, here I'm actually attaching something to the DOM. What am I attaching? I'm attaching this element, which is my header, but of course my header, sorry, my root element, sorry, but my root element refers to the elements above. So I'm essentially attaching everything that I've created here. I'm attaching it to the DOM. This is very old DOM manipulation code. What this expression here is doing is saying, go and find the current element in the DOM that has an ID of that and attach it to that part of the DOM. And if I scroll up, you can see that in terms of raw HTML, I do have a div with an ID of mount point. So it looks like this line here, sorry, this line here is attaching this element and all its children and grandchildren, etc. It's attaching it to the div there at the top. It's attaching it to this part here. So it's very long-winded, ugly coding though. If we had to write all our Java or React code like this, then that just wouldn't be fun. Just to show you the importance of this line here, if I comment this line out, by the way, the web server that I'm using there in the background that I kicked off, the HTTP web server, it has a nice feature built into it, which is called live reloading. So anytime I change a file here, it will reflect that in the browser for me. So I'll just comment out that line, go back to my browser, and oh, sorry, maybe I should save it as well. Go back into 01. And suddenly I see nothing. And of course I see nothing because I've attached nothing to the DOM. Okay, any questions about that, I wonder? No. A marginal improvement is in the 02 file. Let's see what 02 produces. Actually produces the exact same output. Produces the same output. How it creates it is just slightly different. And before I look at 02, if I go back to 01, I'll just undo the commenting that I did. Something that I could do here is instead of declaring this variable here and assigning it to that, I could have just done this, right? I could have said, well, let's just get rid of the variable and just substitute what it's assigned to directly in here, because this is the only place the variable is used. So if I got rid of that, and if I copied all of this code and paste it down here, and assuming there's no errors, are there any errors? Let's see. think there is, and I'll just save that. I mean, I can effectively now get rid of this. Take all that out of the picture. And that shouldn't change anything if I save that. Assuming I haven't made any syntax errors now. Look at 01 again. Okay, so it still renders the same as before. You know, it's only a tiny little improvement in terms of the code, but I could continue on doing that. By that, I mean, instead of having the list here, the list variable, I could just substitute what is assigned to the list variable up here. And instead of the item 1, 2, 3, and 4, instead of using those variables, I could just put in the actual code that they're assigned. And if I keep on doing that substitution, then what I effectively finish up with is this. Okay, so I'm only declaring one variable, and I'm nesting a lot of my React.createElement invocations into the assignment to that variable. That's all that's going on here, really. And then I do the React DOM.render as before. You know, it's only marginal, there's physically less code, I suppose, but it's still quite an ugly thing to actually have to write if you had to do that manually, which we don't. Okay, so that's this idea of nesting invocations of React.createElement within an invocation of React.createElement. It's actually kind of important to appreciate that, though, as we'll see a little bit later on. You can go back and look at it later on if you want to, anyway, if you're not sure as to what I was getting at there. So we have seen how to use the React framework to construct a, albeit static, web page, but we're doing it in a kind of a programmatic or in an imperative programming style. At the bottom of the screen there, I'm contrasting imperative programming and declarative programming. These are terms you may have heard back along. All of the Java code that you wrote way back, we could describe the style of coding that you were doing as imperative programming, where you have a series of statements and control flow, and all of those things are really important. That's one programming style. Another programming style is called the declarative programming style, where you're more concerned with expressing the logic associated with the code, and the runtime environment takes care of the flow of control for you. And it's this declarative approach that we will be using in React. Up to now, what I've just shown you there in the last few minutes was using the React framework to implement a user interface, but using an imperative programming style. And as I've said a couple of times, it's not really that an enjoyable developer experience. And that's why it's never used directly by the developer. Svelte also has this declarative programming style. So how do we implement our user interfaces following a declarative approach? And the answer is we use a syntax called JSX. JSX, it wasn't actually created by the React team. It existed as a separate library, but they adopted it. And since then, really since they started using it, a number of other frameworks use it as well. So this JSX library, sorry now about the chainsaw in the background. One of my neighbors decided today was a good day to bring out the chainsaw and start cutting stuff, but I don't know if you hear it or not. Anyway, JSX allows us to implement user interface descriptions, because we're still only concerned with kind of static stuff, in a declarative programming style. And what's nice though about JSX is that we still have the full power of JavaScript available to us when we're coding our UI descriptions, and we see evidence of that further down the line. And this JSX syntax allows us to couple our UI description with our UI behavior, which I've mentioned already, even though we're not dealing with behavior at all today. The thing you have to remember though, but it's something that exists in the background, is that this JSX syntax that you write at the end of the day, the browser doesn't really understand JSX syntax. It has to be converted back into plain old JavaScript. And by plain old JavaScript, I mean the type of JavaScript that we've seen there a few moments ago. It always has to be converted back to that before it's sent down to the browser, because that's all the browser understands. That transformation process is what we call transpilation. And there is a tool that does that, which we never need to worry about, but it's there in the background. You've probably heard of it before. It's called Babel or Babel. Babel is a tool for converting any kind of modern JavaScript, including JSX, back into what's called ES5 JavaScript. I'm sure you've heard of Babel in the Enterprise Web module. So to get our first look at JSX, we're told to look at this file 03 JSX, and I've purposefully put error in the file name. It's a HTML file again, but I've put error in the file name because it doesn't actually work. And I'll explain what I mean by that in a second. Let's close off these guys. So our objective is the exact same now as before. We want our header and our list of languages, but we want to use JSX this time. And here's our embedded JavaScript code. And really JSX, what am I doing here? Sorry, I'm declaring a variable, and I'm assigning, essentially I'm assigning some HTML to my variable, although technically we call this JSX code, even though it doesn't have any JavaScript buried inside it. It's just plain old HTML. But I'm assigning that to a variable, and then I'm doing my React DOM.render as before. I'm attaching that element to the DOM. Now, if I try and run this though, this web page in the browser, which is 03. I don't get anything. If I open up the developer tools, it's telling me that it doesn't like this less than symbol, which is appearing on a particular line in my code in the HTML file. And the line that it's referring to is it doesn't like this symbol here. And of course that makes sense, because that's not a valid symbol in plain old JavaScript. So it doesn't understand it. What needs to happen is we need to take this, or somehow this JSX syntax, I keep referring to it as JSX, even though it's plain old HTML for now anyway. I need to transpile that or convert that back into the kind of code that we saw earlier on. We're still trying to do the same thing. We're trying to create a bunch of nested HTML elements and then attach them to the DOM. But I can't code it like this in a standard HTML file and send it down to the browser and expect the browser to be able to interpret this. That code that I've highlighted needs to be transpiled, first of all, before it can be sent down to the browser. Okay, so how do we do that? How do we do the transpilation? Well, a manual way of doing it is, there is this website called babel.js, which you can see here. You won't actually be using it very much. We'll use other tools, but for now, we'll make use of it. And if I click on this, try it out here. What this online tool allows me to do is I can put JSX code in here, and it will convert it into plain old JavaScript over here. So let's do that. Now, what you see on the right is, surprise, surprise, there is react.createElement. There's some extra kind of annotations being added in there as well, which I'm not too interested in. But this is what we need to give to the browser, and it can interpret that, and we've seen that already. So this is manually transpiling my JSX into plain old JavaScript. Now, I did that beforehand. And if I move on to 04, in the 04 file, I'm referring to a local file, this one here. And inside that file, I've got the code that you saw on the right there of the online tool, which brings me up to here, because if you look at the path name that's being referenced here, it's referring to something up inside in this folder. And I've got 204 files. I've used a sequencing system so you can follow what's going on here. I've got 204 files. I've got one that is post-transpilation and the other one which is pre-transpilation. This is the pre-transpilation one. This is what we write as developers. What we send down to the browser, though, is this. So we're getting one step closer now to proper React code, which is this here. This is how a little bit closer to how we write React code. We use our JSX syntax to implement the UI description part of our components, even though we haven't seen what a component is yet. Okay, so that's the REPL. I'm just referencing it. You won't actually be using it a lot though, but if you wanted to play with seeing what the equivalent plain JavaScript of some JSX is, then you can use this tool. It's kind of a learning tool, I guess, if you like. So we've now reached this JSX syntax, and I'm saying there that JSX is a HTML-like markup language. Technically, it's XML. And we implement our UI descriptions using this JSX syntax. It is effectively HTML with some minor, very minor differences. We've already seen one of them. In your JSX syntax, you can't use the class attribute when you want to associate a CSS class with a piece of HTML. You've got to use the class name attribute instead. We've already seen that, and that's pretty much the only difference you see between JSX and what you know from HTML. There's another common one as well, which is this one. But apart from that, there's very, very little. And that was a nice thing about JSX from a learning point of view. People that were coming new to React, because they were very familiar with HTML in terms of the syntax and the way we structure HTML, it was very easy to pick up this JSX syntax. That wasn't the case with templating, which had a lot of differences between itself and HTML. It allows the UI description to be co-located with, it allows it to be coded in a declarative way. So we're just describing what we want our UI to look like, and the transpiler, the Babel transpiler, will convert it into plain old JavaScript code, which implements in an imperative way how the actual UI is constructed programmatically within the browser. And we can inline our JSX in an ordinary JavaScript file. Now, okay, granted, the JavaScript file that we have has got nothing else other than, the JavaScript file that you see here has got nothing other than predominantly JSX, but we could have other ordinary JavaScript stuff going on there as well. I could put some JavaScript code up here and maybe declare some variables, initialize them, etc., and refer to those variables down here. We'll see later on how we do that. So it's all a bit clumsy so far, but hang in there. Transpiling, just one or two words about it, even though it's something that goes on in the background. It's done by, fortunately, there is just one tool that dominates this whole transpilation market, or it has emerged anyway over time, and it's this Babel platform. How do we actually do the transpilation? Well, we could use that REPL online tool, and that's nice as a learning aid. But once you get into any kind of real development, then it's obviously far too slow and it's manual. There is a command line version of it as well that we can install, but that doesn't get us very far. Instead, what we tend to do is we tend to use HTTP web servers that have special instrumentation built into them, which does the transpilation for us. So we, from a developer's point of view, we get this kind of experience where we're writing our React application and we're editing a file, we save the file, and when we save the file, there's a web server behind the scene which picks up the fact that we've made a change to a file. It retranspiles that file and sends the updated file down to the browser so that we can see straight away what is the effect of the change that we made. So we get this kind of live reloading experience, and I'm sure you're familiar with that from the enterprise web stuff that you've done. And we'll be doing that a lot actually throughout the remainder of this module. There is a third approach. This live reloading is great from when you're in development mode, but eventually you'll want to deploy your React application so it can be used by the world in general. So we can't have live reloading going on in our server when our application is deployed for general use. So there are build tools, or more specifically, they're referred to as bundler tools, which essentially take all of the code that we've written for our React app, gobbles it all up, transpiles all of it, and creates a single minified JavaScript file that represents our entire application. You'll actually see that being used, believe it or not, in the second lab for today. So you'll get a sense of what I mean by that. I'm sure you've used bundlers in the enterprise web as well. You may have, I'm not sure. If you've done deployment, then you certainly would have. So 2 and 3 is what we really use as proper developers to carry out the transpilation for us. And as I've said already, it's just something that's there in the background. We don't need to worry about it. Now, I've banged on about components, but we haven't actually seen a component so far. What is a component from a coding point of view? And it is simply a JavaScript function that returns a piece of UI description. It returns JSX. Its return statement contains a snippet of JSX. That's all a component is from a structure point of view. And when we create our component functions, we can actually, you could think of components as an extension to the HTML syntax itself. So you can refer to components like this, right? You can actually refer, I mean, it looks like here that component X is a piece of HTML because we're using our angle brackets and so on. And that's really what's really nice about React is that we are using the well understood syntax of HTML, even though it may contain within it references to custom components that we've written. And of course, we know that those components behind the scenes get transpiled, etc., and they contribute something to the UI. So it's a function, a React component is a function that returns a piece of JSX, and we can refer to it somewhere else in our React application. We can refer to it using this HTML-like syntax that you're familiar with. Hence the kind of composition that we'll see later on. So finally, we get to see a component in sample 5 we're told to look at. So we're still in the same project. And here, now we've gone now from embedding our JSX in our HTML. We know that doesn't work anymore. So in terms of the HTML, again, it's referring to a local file with the 05 prefix. And I've got two versions of the 0.5, the pre and post transpilation. The pre-transpilation is this one. I'm going to close off the other files first, sorry. And I'll just open this one as well. So here's a React component, and as I said, it is a function. I'm using the arrow syntax. You don't have to use the arrow syntax, but it's the one you see most commonly. It doesn't have any logic in it at the moment because we're not dealing with behavior, but you can have any kind of JavaScript you want inside here. And as the slide said, it returns some JSX, albeit static JSX, which really means it's very, very close to HTML, although it's not pure HTML because, you know, we have to use class name here instead of class to refer to our CSS. And again, the CSS is being pulled from my CSS file down at the bottom here. So here's our first component. So as a developer, this is what you write. What's sent down to the browser is the transpiled version of that, which is this. But you know, you never need to really, if you're doing proper development, you never think about that. You think in terms of this kind of coding style. You don't worry about what it materializes and what's sent down to the browser. But I keep saying it for this particular lecture because it's always this React.create element that's being used all over the place in the transpiled version. And so my HTML file is referring to this file, which is the transpiled one. But as a developer, this is what you write. And however you convert the source code into transpiled, which, as I said, will really be done by a web server that's running in the background. Even though I did it for this particular example, I did it using the online tool, the REPL tool, but that was only for the purpose of this illustration. And 0.5 is, you know, it renders the exact same as before. Which one are we on, sorry? Okay, so what you should do is you should, in your own time, go to the website, grab this archive, download it, unzip it, open up the README, click on the YouTube reference, and just follow the video which explains how to set up VS Code with that little HTTP server, and then you can play with it, play with these samples. Although I wouldn't spend a whole lot of time really, but just play with them a little bit maybe before you move on to maybe looking at the labs. Right, that's our first look at a React component. We need to come back to them though, because our components are pretty useless at the moment. They're just static. They don't do anything in terms of, they don't allow user interaction. They don't change based on the user action. So that's not great. And they're completely unreusable, if you like. But I'll just go off on a tangent for a second and talk about developer tools that React developers use today. And there's one in particular, although I will mention two. There's a tool called Create React App, and surprise, surprise, it's a tool for creating React applications. And it has all of the features that you would be familiar with from tools that you would have used in the enterprise web, in the sense that the Create React App tool, you install it as an npm install, well, an npx actually. And what it will do is it will scaffold or generate a template folder structure for your React app based on kind of best practice, although there isn't a whole lot in terms of what it auto generates. It also comes with its own web server, which takes care of auto transpiling your code and pushing updates of your code to the browser to show you what changes you've made, how they've reflected in your React apps, what it looks like in the browser. So there's kind of live reloading. It also comes with its own bundler, this tool that you use to construct a production version of your React app. And you'll be using this tool in the second of this week's labs, just to get you familiar with it. That's one tool. The second one, so Create React App, is a tool that you use when you're developing a React application. Storybook is a tool that you use when you want to develop individual components. And you want to see, well, how does this component render in the browser? And so it's nice. The Storybook tool is nice in that it allows you to work with individual components. Now, eventually, of course, you're going to be bringing these components together to form an app, but it does allow you to actually isolate just one component and see, is it rendering properly on the screen before you even start thinking about attaching it to other components to form an app. The Storybook tool, so I'm saying it's a development environment for React components. It allows us to create components in isolation, which I've already mentioned. What's kind of nice is that when you develop components in isolation, now admittedly you need to be kind of maybe an experienced developer, but it does allow you to develop components that are potentially more reusable. It almost kind of tricks you into doing that. You naturally develop components which will be reusable in different kind of contexts in terms of how you configure them. And also your components tend to be more testable, even though we won't get into testing. And because you're developing smaller units, you're developing individual components rather than entire apps, then your speed of development is quicker as well. I want to spend a little bit of time talking about Storybook, because the Create React App tool, you install it and you go Create React App space, whatever you want to call your app, hit return, and that's it really. You don't tend to use it. There aren't many command line arguments that you use with it, and it's just one of these things that's in the background. Its main kind of benefit is this server, this development server that comes with it, which you will kick off in the background, and you just let it sit there and it monitors changes that you're making to your source code. It'll also load your application into the browser so you can see what the app looks like right now. And as you change it, it will push the changes to the browser. So it's very much working in the background, but it is at the app level. Storybook, as I said, is at the component level. So I want to talk a little bit about Storybook for a few minutes, because it's going to form the first of this week's labs. And my kind of rationale is that it's probably better that you, first of all, just get a little bit of experience of developing individual components before you start thinking about the bigger picture of an app, even though from the next lecture on, we will be developing apps rather than individual components. The Storybook tool, you install it as an npm install as usual. There are two parts to the tool. It comes with its own web server, which does all of the things that I've been talking about up to now. It does the automatic transpilation and retranspilation whenever you make changes to your component file. And it also performs live reloading, so you can see what the effect of your changes are in the browser. Secondly, it has its own kind of user interface, its browser-based user interface, which will allow us to browse our catalog of components. So it comes with a server and it comes with its own user interface, which is not surprisingly a browser-based user interface, because we are developing components that we want to be able to use in a browser. When you start up the Storybook server, what it does is it looks through your code base, finds all of your components, and you've got to tell it, okay, where are the components? What folder are they contained in a small little bit of configuration file. It finds all of those components, reads through all of the component files, also then just displays all of your components on the left-hand side. So this is the Storybook's UI user interface. This is what it looks like. It shows all of your components that you develop, individual components on the left-hand side. These will be clickable. And when you click on them, it'll show you what the component renders like. Okay, so it's only focused on individual components. Sorry, no. Oh yeah. You might wonder where does this term kind of storybook come from, or how do they come up with the name storybook? And what a story is, it actually comes from the user requirements analysis space, which you may or may not have covered. But the idea is that a component, I'm saying here, a component may have several states. And by states, I mean it relates to the data associated with that component. The data may have different values, and the value of a particular data variable within a component may influence how that component renders on the screen. And each of the state values is referred to as a story. Now let's try and make something tangible here. So a while ago there, I had a component that displayed a list of programming languages. And let's supposing I call that component, all the languages happen to be dynamic as opposed to static languages. Let's supposing I call that component my dynamic languages component, and you saw what it did. But let's just say that I want the component to render slightly differently depending on how many languages it has to display in the list. I've just arbitrarily come up with this now, right? Let's supposing if there are 5 or less languages, then it should just display the languages as you've seen. I'm going to refer to that arbitrarily as my default state or my default story for the component. If there were no languages, if it got a list of 0 languages, then rather than the component displaying nothing, I've decided I wanted to display just a simple little message on the screen. And thirdly, if it got more than 5 languages, the way I want the component to render is to display the first 5 and then have a little more button, which if the user clicks on, it'll display the next 5. So I would refer to these as 3 different states or 3 different stories associated with my component, my dynamic languages component. Don't worry about how do we come up with these stories. Let's not worry about that for now. Just get the idea that a component can have a number of different states associated with it. The states we refer to as stories are often referred to as stories, and each story has a slightly different rendering of the component. And it's up to you, admittedly, as the component developer to identify what are the different stories and also decide how do you want the component to render for each of the particular stories. So a component has this notion of states or stories. And what actually happens then is when in your storybook kind of user interface, you see your components on the left, but embedded within each component will be the different stories associated with that component. The name you give to the stories are completely arbitrary. Obviously, you give them some sort of meaningful name. And if I just go back to the previous slide, default, boundary, and exceptional are arguably meaningful. Boundary, as in, if it gets 0 languages, then that's kind of a boundary condition. But we still want our component to be able to deal with that. We've got to decide how it should react to it. Exceptional if it gets more than 5. The norm would be when it gets 5 or less. Okay. So from a storybook point of view, you have components, and then you have different states or stories associated with that component. And this is how the storybook tool will display those to you. In a very large software project, you may have a large catalog of components, and rather than listing them in a long linear list here, which can be difficult from a searching point of view. You can group your components into groupings or categories, and the Storybook tool allows you to express that so that you see something like this on the left-hand side. Okay, you can have a category name, the components belonging to that category, and it's up to you again to decide what are meaningful categories based on the nature of the sets of components that you're developing. But for now, I'm just saying that the Storybook tool allows you to structure how you list the story, how you list components. It allows you to structure them into groups. So it just makes it easier for people that are browsing your, I guess people within your software development team, to browse through the various components that make up your React application project. Now, when you're using Storybook, you obviously have to implement your components, but you also have to implement stories or write the stories, because it's the stories that you write, that's what Storybook uses to allow it to essentially create this listing here on the left and this kind of stuff here. So we have to write stories for each component. By convention, we put the stories into a file with this extension, although it's purely conventional. It is a JavaScript file, so we do implement our stories in ordinary JavaScript. And we have one stories file per component, again by convention. And I'm showing you here an outline of a stories file that I have implemented. And again, I've stuck with the dynamic languages component that I've been talking about up to now. So it is JavaScript. I'm importing the React library, naturally enough. This file now only makes sense to the Storybook server, I should say that. I'm also importing the component that this particular file has stories related to. Now, from a coding point of view, you first of all have to have a default export, and the export, you assign it an ordinary little JavaScript object, and essentially this object here contains metadata about the particular component that these stories relate to. For now, the metadata is only comprised of two parts. What title do you want to give to the story, and what component is this stories file all about? The title here, it is just an ordinary string, and it can be anything you want to, but typically it contains the name of the component, even though I am allowing space in it, but it is a string. Whatever title you use here, that is what the Storybook server uses to control what it displays kind of over here. So we've got a default export which contains metadata for this particular stories file. And then we've got a whole series of functions which implement a story for that component. So you've got a default export and you've got named export, and each named export corresponds to one story. A story is implemented again as a function, as a JavaScript function. And I'm using the arrow syntax, but you don't have to, but it's the most commonly used one. This function, you can have any logic you want to in it, but it has to return an instance of the component that the story relates to. And again, I'm referring to my component using the angle syntax, which I've talked about already. This is technically JSX here. Now, we haven't seen it so far, but this component, my dynamic languages, I obviously have to pass the array of languages into it. Sorry, just 1 second now. Yeah, I know I'm going to be on time now. Am I going to be on time? I am, yeah. I'm just going to finish this slide, and I'll let you go then, but let me just finish this slide if that's okay. I'm creating just an array of languages, and I'm passing the languages down to my component. We can't make sense of this right now because we haven't seen it, but that's okay. All I'm interested in this particular slide is showing you the outline of a stories implementation, default export, and then a named export for each story implementation. And so it looks like I have 3 stories here implemented for my dynamic languages component, and that correlates with what I was saying on the earlier slide, that we wanted we came up with 3 stories for our dynamic languages component. Sorry, I'm not going over time. 2 o'clock is my scheduled completion time, isn't it? Yeah. Sorry, I misread the clock there actually. Okay, I'm going to keep going if that's all right. So writing stories. The only thing I'm showing you on this slide here is that when I was covering this with last year's class, the way we implemented stories from a syntax point of view has changed. So if you start Googling around Storybook and implementing stories for React, and you see this kind of syntax here, then you should stop, because it's the old syntax. The newer syntax is what I've just shown you there. The old syntax was much more long-winded, as you can see there. So we have our component in a file, and we've implemented stories for that component in a separate file. And I'm not getting into the detail of how you come up with the different stories, how you decide what data you should pass into a component. I'm not dealing with any of that now, and you needn't concern yourself about it. It's just the mechanics of using Storybook is all I'm interested in. Earlier on, I said that you can group your components into categories, so that if I just go back, so that you can get this kind of effect here. And the way you express that in your story implementations is what I'm getting at here. Turns out that in the title part of the metadata little object that you create, you can see here in the title, I've got a category name followed by the component name, but I've got a slash in between them. That slash is significant. The Storybook server interprets that slash to mean that what's to the left is a category that I want to have for my components, and on the right is the actual component itself. And you can have categories within subcategories if you want to, but the slash is how it determines that you are grouping components for the purpose of displaying them on the screen. And you can see if you look down through here, I've got a number of other Storybook files. I've got group A again, so it looks like these 2 components I want to associate with group A, but then I move on to group B and I've got another component. So that's how you syntactically tell the Storybook server how you want to group your components and how they should be rendered on the Storybook UI. I want to go back to components though, because all we can do so far is just write a purely static component. We can't pass any data into it, and it's not in any way flexible or reusable. In order to cover the remaining slides in this set now, I've got another archive, and in this case, the archive is part of this lab here. So when you go into this lab, there's an archive here that you download and zip it, import it into VS Code, and what you finish up with is the following. So this is also a little node project because it has its package.json, which you're familiar with. And if you look through the JSON you'll see that as well as React, I'm also importing storybook stuff. Now, this project on the left, you see when we start up the storybook server, this is what you see. So what I've actually done is I have created a set of components, and I have stories associated with those components, which I'm calling my sample components and the sample stories. So you can see here, there's the sample category that has a couple of, now in this case, I'm just, in terms of, I'm not using the component names, I'm using slightly more expressive names, so just to help you to relate a particular story with a component, etc., etc. So I've kind of given them numbers, but ordinarily it would be kind of a component name that you might have here. So I've got what is it, 4 or 5 different sample components, and I've gotten stories associated with those samples, and each of the samples will illustrate a particular aspect of JSX which I want to explain to you. And then up here, then I've got an exercise category, and in the exercises category, that's what you will be tackling in the lab, depending on how far we get in this now. On the right, I'm showing you the structure of the actual archive that you will import into Eclipse. And so it's got a source folder with a component subfolder. And inside the component subfolder, I have all my sample components inside here. And the exercises folder is where you will be implementing your components. Down here, then I've got a stories subfolder within source, and it's got 2 subfolders with what you might expect inside them. Up here as well, when you're using Storybook, we tend to have a .storybook folder which contains configuration information that Storybook uses, and you never really need to go in there and change that. I've already set that up for you. So what I want to do is to step through the samples, and each sample, as I said, will explain a particular aspect of JSX. So I've ran npm install already on this project. And in order to run the Storybook server, what you need to do is open up an integrated terminal, and I explained in the video earlier on how you do that. And to run the Storybook server, in this case, it's going to be npm run Storybook. Now, behind the scenes, the Storybook server is going through all of your code, and suddenly it renders its the Storybook UI, and we see here our components on the left-hand side broken up into the 2 categories that I've talked about. So we're only interested in the samples, in the sample section. And so we'll start off with this one. Okay, and it looks like it's that familiar one that we've already seen. Now, the first thing I want to explain is how do I embed variables in my JSX? The JSX that we've seen so far didn't have that capability. So we're taking small steps. So here I've got a component, and within the component, I'm declaring some variables. And again, I'm sticking with my kind of list of languages case study. So I've got a standard little array containing a list of 3 languages. And it's purposefully 3 exactly now, which isn't very great, but I'll make it more flexible in a while. And I've got a string as well that I'm assigning to a variable. And I want to refer to these 2 variables within my JSX. And so on the top of the screen here, I'm saying that when you want to embed variables in your JSX, you need to wrap the variables in curly braces. And what happens at runtime is the React runtime will evaluate what is inside the curly braces, and the result of that evaluation is what it includes in the actual JSX. So it evaluates it at runtime. And so we can see down here in my LI elements, for example, I'm referring to the languages array that I created at the top, and I'm indexing into it. So the curly braces here and here, if I take out those outer curly braces, then all that will be rendered on the screen is the actual string LANGUAGES brackets, etc., etc. But because I've wrapped it in curly braces, it evaluates this first, and it takes the result of that evaluation, and that is what it includes in the browser's rendering on the screen. You can actually have any kind of JavaScript expression that you want to inside here. And in fact, if you look up here, I'm declaring a H1 header, and I'm using my JSX curly braces. So I'm asking the React runtime to evaluate what is inside these outer curly braces. But what I've actually got inside here is a JavaScript template string. And we know from template strings that it has to, first of all, dereference any variables inside the template string. You've seen this kind of syntax before. So this is just JavaScript templating, string templates going on, and it's evaluating this variable. So eventually, anyway, it constructs the string. It evaluates this entire string from a JavaScript point of view, and then it takes that evaluation and it inserts that as my header. So technically, this is kind of a JavaScript expression that has to be evaluated first before we can decide how it should render it on the browser. Now, this is the 02 sample. So if I go back to my code, so what I need to look at is I need to look at the source code for the component, and I need to look at the story for the component. So I've shown you that. The story is down here. And again, use the numbering to help you. Whether it was a good idea or a bad idea, each of these files has almost the exact same name, component.stories.js. So that's not very helpful, but the numbering hopefully will help you. So the stories is this one here. And samples /02 JSX embedded. That is what we see here. And when I click on it, it renders that. And is that consistent with what was in my code? Just going to leave that open. Yeah, that seems to add up okay. So the only thing we've learned is how you can embed variables or indeed expressions, expression here, variable here, how you can embed those in your JSX by using the opening and closing curly braces. A slight improvement, but only very slight in our journey through JSX. Wouldn't it be better though if we could actually pass the array of languages and whatever kind of name we wanted to give the category of languages, if we could pass that into the component, then our component is much more reusable. In other words, we want to parameterize the component. Now, in the language of React, we talk about passing props, which I guess is short for properties, passing props into a component, where the props is data that we want the component to render for us. So components or props or attributes is data. For now anyway, it's data. We'll see that props is much more flexible than just data, but it'll do for now. Is data that we pass into a component. So there's two things. A, how do we, from a syntax point of view, how do we pass the data into a component? And secondly, how does the component access that data internally? And that's what I'm getting at here. So it's kind of sticking with the basic syntax of HTML, really. This is how you pass data into a component. You use this syntax. So whatever the name that you want to give to the piece of data, and you assign it the value that you want to associate with that name. Again, the value has to be enclosed in curly braces because this has to be evaluated before it can be passed down into the component. A typical mistake that people make is that they leave out the curly braces here. They think in terms of standard kind of HTML syntax. So it looks like I have a component and I want to pass in a parameter or a prop. The name I want to give the prop is prop name, and I want to assign it that value. I also want to pass in, prop1 name. I also want to pass in a parameter or prop called prop2 name and give it a value, and so on and so forth. Inside the component, then, this is how we actually access it. So a React component, as we know, is implemented as a function. Now, there is a default parameter for that function. Now, you can call it anything you want to, but conventionally, we call it props. This props parameter is going to be instantiated as an object, a JavaScript object by the React library. And that object is a JavaScript object, so it's going to have a set of key value pairs. And the key value pairs are going to be based on what you've written up here. So for this particular component, this props object is going to have a key with the name prop1 name. The value associated with that key is whatever this is. It's going to have another key called prop2 name and whatever value associated with that. Inside in the actual component function, then it looks like I'm just dereferencing the key value pairs within my props object. That's all that's going on here. And so presumably in the JSX, I can now refer to P1 within my JSX, where P1 is going to be this value here. So this is how we make our components reusable in terms of passing data into them. We pass props using the techniques that I've just shown you there. Some things that you need to know about props, which aren't obvious. Number one, I'm saying props are immutable. You cannot change the value of a property inside in the component. Even though you might, syntactically, it'll allow you to do it, but it won't reflect it. So they're immutable. And number two, I'm saying they're part of a component's design. And again, you're going to have to just take that for now. I'm not going to get into how do you decide what properties are appropriate for a component. Usually it's fairly straight, it's fairly obvious, but it is part of a component's design. Or when you are designing a component, it's part of the decisions that you have to make, as well as how you want the component to render on the screen. You will have to decide what will be meaningful props to pass into the component. So let's see this in action. So sample 03. What does 03 render like first? It's probably the same old story. Yeah, okay, it's an array of languages, different title, different languages. And the component, I guess if we look at the story first, we know now that, I suppose it would make sense for this component that we pass in the array of languages, and also maybe we pass in the category or the title that we want to associate with this array. Yeah. So if I look at the story first, we haven't looked at the component, but I'm importing it here, and that's just my metadata. And here I am outside of the component. I'm creating my array of languages. I'm creating the title or the category that I want to have associated with those languages. And here we go. I'm invoking my component, and I'm passing that data in as props to that component. So that's my story, and the component then looks like this. Props object, and I am dereferencing them actually embedded within the JSX. So that's kind of nice there, this idea that I didn't have to do this kind of stuff. Sorry. I didn't have to do it, inside here. I can just do the dereferencing embedded within the JSX. If I did want to refer to this stuff and do some computation with it, then obviously I would do it up here, but it didn't arise in this case. So that's this idea of passing data into a component for the purpose of making it more reusable. Before I talk about the next sample or the next aspect of JSX, I just want to, well, I guess in your case, to refresh your memories about one or two aspects of JavaScript. And you've done a lot of JavaScript now, so this is probably fresh in your memory. But with JavaScript, arrow functions, there a lot of the syntax associated with an arrow function can be omitted in certain cases. So for example, if you take this simple little arrow function here, where the arrow function only has one statement in its body, and that statement is the return value, or we want that statement to be the return value of that function. When that arises, then we can drop the curly braces, we can drop the return keyword, and we can finish up with something like this. Right. So those two are equivalent from a syntax point of view. This is obviously a much kind of quieter syntax than this one up here. So that's just a JavaScript feature. The other thing that I'm just reminding you about is the JavaScript array map method. I appreciate now I'm over time. I'm just going to finish on this one and I'll let you go then. And I'm pretty sure you've used the array map function in the enterprise web. Just a quick reminder. Here I've got an array of objects. And in this case, I've moved away from the language thing because we've had enough of it. But in my objects here, it looks like I've got an object that contains some key value pairs related to single page app frameworks, a framework name, its home page, and so on. So either way, it's just an array of JavaScript objects. And here I'm mapping over that array. And we know what the map method does. It calls the function that you pass to the map, and it invokes that function once for each object in the array. And whatever that callback function returns, it puts the return values into an output array, which I can assign to this. So this variable here is going to contain an array of elements, and the elements in it will be dictated by this callback function that I'm passing to map. I'm kind of assuming now that you are familiar with this. So I'm just showing you here what the names array, I'm showing you here what the names array should contain after this is executed. But the key thing is to make sure you're comfortable using map, because we're going to be using map quite a lot actually. This is something you don't know. I can assign a piece of JSX to a variable. That's a valid assignment statement to do in a React component. And that looks very unusual at first sight, but I'm posing the question, why do you think it's going to be possible for us to make that kind of assignment statement? And the answer is, if you think about what happens to this JSX, this has to be transpiled back into plain old JavaScript. And when we transpile this piece of code into back into plain old JavaScript, what we get is that. And now that makes kind of sense, all right, to be able to say, here I'm just invoking a method of an object, and whatever that returns, I'm assigning it to a variable. That makes sense from a pure JavaScript point of view. Okay, the fact that I've got nested invocations inside it slightly complicates it, but it's still a standard JavaScript assignment statement. So, and this opens up an awful lot of possibilities for us. The idea that we can assign some JSX to a variable, that means we can pass JSX around the place from function to function potentially. But for now, all we're interested in is realizing that that's a valid assignment statement to make. Now, if I bring all of these things together, the idea that a lot of the syntax associated with arrow functions can be omitted in certain circumstances, the ability to map over an array of objects to produce an output array, and this type of assignment statement. If I bring all of those together, then we can actually do something quite powerful. And the use case for this is, supposing I want to generate an array of JSX elements from a data array. In particular, let's supposing I want to generate an array of LI elements, where in this particular case, the elements has, hyperlink nested within it. And presumably from a data point of view, this URL and this name here, this is the data that I want to put into an array, and from that data array, I want to generate an array of LI elements. That's kind of my objective, which is kind of close to what was going on here. Okay, instead of here the callback function is just generating a string, but supposing the callback function generated a JSX LI element, that would mean now that this names array here would be an array of LI elements. And that's what we're doing in sample 4, and I'll leave it at sample 4 now. I've gone on far too long. So I'm just going to close these off. What sample 4 renders is this, and the story for it so I've got an array of objects, which we've kind of already seen, and I'm passing that array into my component. Okay, so I'm passing in my array of objects, and I'm passing in this string as well, which isn't too important. Now, it's what this component does with this array is what's of interest to us, though. And you can see here that I'm mapping over the array, and in the callback function that I'm passing to the map, what is returning is this. So the list variable is going to finish up as an array where each element in the array is an instance of this. And I'm doing some dereferencing inside here. The array of LI elements, the only one that I need to explain is what's this about. It turns out that in JSX, if you've got an array, well, sorry, just before I explain that, sorry. All I'm doing down here then is I'm just rendering that list. So that statement there is what generates the array. There is a recommendation from React, which is if you've got an array of identical types of elements that you want to render, then it helps the React runtime if you give each element in that array a unique identifier. And that is what's going on up here. I'm giving each LI element a unique key or identifier. So technically this is a prop, and this is the value associated with that prop. But in this case, this prop is used by the React runtime library. And the keys are just the index number of the object in my array. So it's going to be 0, 1, 2, 3, etc. Other than that, this plays no role in terms of controlling how the component renders on the screen. It is used by React behind the scenes, and I wouldn't get into rationalizing what exactly it uses it for. I can come back to it maybe at a later stage. So what's nice about our component now at this stage is that it's both reusable and adaptable. The reusability is facilitated by the props idea. By adaptable, I mean that it doesn't really matter what size the array that's passed into it is, the component is going to adapt to that. What I mean by that is if I go back to the story, and if I just arbitrarily double up the size of the array, like so. Now, when I save this, Storybook is going to retranspile my code and update the UI, but I haven't made any change to my component. So I'll save it, go back to the browser, and voila, it has adjusted accordingly. So we know at this stage that a component function returns JSX. The JSX that it returns could be as simple as this. It returns actually another component as its return value, or it could be a little bit more involved like this here. When the return is a multi-line, which this is, then you have to wrap the multi-line statement in parentheses. Otherwise, the transpiler gets kind of confused. The return has to be a single element. Now, for example, here, this isn't going to work. What we're trying to return here is a header, followed by an instance of my component, followed by a paragraph. That's 3 separate elements. Now, we know from general kind of programming that a function or a method can only return one value, if you like. Here, we're actually trying to return 3 values. And then again, this goes back to how this transpiles. This would transpile into 3 invocations of React.createElement, but the 3 invocations are not nested. They are separate invocations. So that's not going to work. And this is another kind of common mistake that you might make at the beginning. It's easy enough to solve it though. All we've got to do is wrap this particular piece of JSX, wrap it in a div, and now we just have one element that's being returned. Showing at the bottom here the error that you would get in the browser's console, developer tools console. So the solution, or a solution, is to wrap it in a div like that. That was kind of the early days solution, But the problem, even though it's minor enough, I suppose, the problem with that approach is that if you've got a lot of components in your application, you're introducing a lot of extra divs, which are going to be represented on the DOM. And these divs play no role other than to satisfy this issue. So, and that can actually impact on the browser's performance because you've got these extra additional divs, which means that your DOM data structure is a lot deeper in terms of its nesting due to that. And what the React team did was they came up with an alternative solution, which I'm showing you now on the right. And the alternative solution is that you use this special tag called the fragment tag. And you'll see me using that a lot in any of my sample code that I give to you. The only time you might use a div instead of this fragment tag is if you want to associate some CSS class with the div, and that arises too. The fragment tag it's not actually reflected in the DOM at all. It doesn't appear on the DOM. And therefore, it has less of an impact on the browser's re-rendering process as a result. Now, this is a big statement, but it's true. All React applications that you will ever develop is going to finish up as a hierarchy of components. You can't get away from that. So, in other words, components can have other components as children, and that depth, that nesting can be as deep as you want it to be. And we know, of course, that props are things that we pass into a component. So what you will see is components having other components as children and passing props down to those children components. Just by way of illustration, I have a sample 5 illustrating it. Again, it's kind of made up example, but in my sample 5, this is what I'm trying to achieve. I want to have 3 components, which one of them is the parent and the other 2 are children of that parent. And the numbering system that I'm showing you there is kind of reflecting the parent-child relationship, where 1 is the parent. So it looks like the component that's represented by 1, it has 2 children, and obviously it passes data down to those 2 children. It also has the parent component also has some of its own JSX, so it generates this bit of JSX itself and this bit of JSX itself. So here's the story file, and I've got my array of languages and I've got my array of frameworks. Now, for no particular reason, what I decided to do was to construct a new object which brings the 2 arrays together. That's all that's going on here. And then I'm passing that larger object into my component. Again, that was just an arbitrary decision. I could have instead passed down the 2 arrays as separate props down to the component that I'm testing here. The component code itself, then it needs to obviously deconstruct this larger object that's passed into it. So here's the component code. I'm importing the 2 child components that I'm using, that this component is using. And here it is actually invoking, if you like, the 2 child components, as well as having some of its own custom JSX. So this idea of a component using other components within its JSX to facilitate what the parent wants to render. This again is a very common pattern, this idea of a parent-child relationship and having a hierarchy of components, where in this case, my hierarchy comprises of 3 components, a parent with 2 children. There's always going to be 1 parent at the very top of the hierarchy, but the depth of the child relationships can be as deep as you want it to be. That's that, and I think that's the end of this set of slides. So we've looked at JSX, which is our way of describing user interfaces in a declarative way. We looked at components, the basics of components anyway. There's a lot more detail we need to go into, where a component is implemented as a function that returns JSX. We've looked at the storybook tool, which allows us to develop components and test them or exercise them in isolation. What I would like you to do, because we have actually covered enough in order to be able to do it, is obviously you should look at the archive. You should also have a go at this lab. And once you've done that, you should be able to do this lab as well. This lab is very prescriptive. This lab is mainly exercises, admittedly, based on what we've just been talking about there. This lab is very prescriptive. It steps you through using the Create React App tool. And there's no exercise associated with it as such. So, okay, you may be flying blind a little bit, but it would be useful to get yourself comfortable using the tool, if not just to install it anyway, because we will be using the Create React App tool for the remainder of this module.